Okay, this is the second lesson in the Vectors and Projectiles section. This lesson today is about vector addition notes, and it'll be pretty similar to some of the things that we did in grade 11, so hopefully it's mostly a review. The first question says, Eric leaves the base camp and hikes 11 kilometers north, and then hikes 11 kilometers east. Determine Eric's resulting displacement. So essentially, really, we just have to add together this first vector of 11 kilometers north plus the second vector of 11 kilometers east. So when we add them together, we're going to use that tip or head to tail method. Of the two, you probably be tempted to put the north one first and then the east one, and that would work, but it actually is better, and I'll show you why in a second, if you do the east one first. So when I draw them together, here I'll use my little line thing here, so I'll do one to the east first of 11, something like that, and then our second one we'll do a north one starting from here, right? So we'll go from there up north, and so now when I label it, they didn't quite fit. This will be our 11 kilometers east. Normally I would just say 11 there, but I'm just being so diligent. Here, this is 11 kilometers north. So our resultant here is going to be, we'll be starting here, and I'll try to do it in the dotted line, and there is our resultant. So I'll put I'll use the letter R for resultant, and here is my angle over there. And just to remember that the resultant, when you're considering, some students are, not quite sure, should I use this angle or should I use that angle? You consider the resultant is going that direction, so you can think of putting an north, south, east, west grid from where the resultant starts, not from where it ends. Okay, so now we're going to be using our Pythagoras. We could say that this r is going to be equal to, or we could start off with r squared is equal to 11 squared plus 11 squared. So r is going to be equal to the square root of, what's 11 squared? 121. 121 plus 121. And so I think it works out to 15.6. Now we're not done yet because we also need to figure out the angle, because displacement is a vector. We want to figure out this angle here, the theta. So theta is going to be equal to, now although we do know all three sides, we have just figured out this side. We did round it off, and also we may have made a mistake there, so it's always best to use these ones. And you'll notice a pattern, we end up using tan a lot. So just to recall, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. That's what we have. Here's the angle, that one's the opposite, this is the adjacent. So if the tan of the angle, here I'll write one line beforehand, if the tan of the angle is equal to 11 over 11, then really from this step to get to that step, what we do algebraically is we do the inverse tan of both sides. The inverse tan of tan theta, so we get rid of that, is theta, is equal to the inverse tan of 11 over 11 is 1, right? So from here to here, what did we do to both sides? We did the inverse tan of both sides. And it's not too crazy to remember that that's 45 degrees. Since it is in the first quadrant, that 45 degrees is 45 degrees counterclockwise from east. So our final answer is, and maybe I'll get a better color out for this one, it'll be 15.6 units kilometers at 45 degrees. And if it's counterclockwise from east, I don't have to put anything else than that. Okay, good to go. The second part here, it says practice adding head to tail from the worksheet. So there's a worksheet. Here's the worksheet for you to do at the end. This one is vectors 2. It's called addition of vectors. So I just stole a couple examples just to help you along the way. When it has a diagram like this and it says resultant is blank, they want you to choose either A, B, or C, which one's the resultant. So looking at this, looking at the pattern, I can see from the end of C, B was drawn, right? And A starts where C started and ends where B started. So this is going to be a resultant, right? Because if I think about the way that they were ordered, the order in which they were written, here is our resultant A. The vector equation, so it's going to be C plus B equals A. So that's the order in which they were added. What is the direction of the resultant? The direction of the resultant. Well, I don't have a protractor with me, but if I go and if I look at where A started from, and I draw the north, south, east, west grid, and I think about how many degrees that is, first of all, it's for sure in the first quadrant, so it's between 0 and 90 degrees. Looks to me like it's less than 45 degrees. I'll do an estimate of 30 degrees in there. Okay, so some of the tools that you're going to be using are Pythagoras, and by that I mean the hypotenuse squared is equal to the 2 legs squared, SOHCAHTOA like we just did, and actually the sine law and the cosine law, which is on the formula sheet, very rarely, so I won't go into it now, but if we do end up using it, we can. Okay. Here's another example from the worksheet about a student moving around. I'm just going to organize this a little bit in terms of our x directions and our y directions. Okay. Now just a reminder what x and y look like. So x is this direction. X is the same thing as east is in the positive direction here, and west is in the negative direction. So wherever I see here, I'm going to go and organize this. Wherever I see an east or a west, it would be those three, right? Then I would put them in, and if they are east, they'd be positive, so plus 16. And if they're west, they're negative, so minus 2, and then minus 46, it's quite the ways. So I can add up all the x's first. So those add up to, I think, minus 32. And then I can take a look at all the y values. So again, north would be a positive y value, and south would be a negative y value. So 2 north would be plus 2, 14 south would be minus 14, and 12 south would be minus 12. So if I add all those together, I think I get minus 24. So well, what does that look like? Well, to go negative 32, that's the same thing as saying, right, remember, negative in the x direction is west, so that's the same thing as saying 32 west, and this is the same thing as 24 south. In fact, I guess I could put that in my answers over here. This symbol here means the sum, okay? This is sigma in the Greek letter sigma, and it means the sum, or net. So the sum of all the east-west forces, that's what this was, 32 west, so I'll put that in, 32 west. And the sum of all the north-south ones is 24 north. Okay, so now what is the overall displacement? So this is the question I need to answer yet, the overall displacement. In other words, what happens when I add together this vector plus this vector? So what do I get? Just like I did before, way up over here, I need to add, here I added these two together, the 11 and the 11. Now I have to add together the 32 west and the 24 south. Okay, so again, I'm going to take my own advice, and I'm going to draw the east-west one first. Okay, so here we go. We'll start from here. We'll go the west direction first. So that's 32 west. And then we're going to do 24 south. So there's my 24. So my resultant would be going like that. There's my resultant. So that's my overall displacement. So this will be my resultant. Okay, and where do I put my theta? I'll let you think about that for a second. The theta, which angle do I want? That would be this angle over there. Okay, and if you recognize the north, south, east, west grid, once I'm done calculating the theta, because it's in quadrant 1, 2, 3, because it's in quadrant 3, I'll be saying, oh, it's going to be 180 plus theta. Okay, you can see how theta is off of that x-axis. It's my reference angle, so I'm going to add that to 180 degrees. So let's do this part. We'll do the Pythagoras part first. R is going to be equal to, so I'll just do square root of 24 squared plus 32 squared. Is equal to, I think the answer is somewhere around 40. And for the theta part, again, you see how it works. Even though we have this side, we're going to use the opposite and the adjacent. So we're going to say it's the inverse tan of 24 over 32. And so I get an answer for that. I think it's 36.9 degrees. Okay, so now again, because of this being in the third quadrant, I'm going to add 180 to that. So I will get 217. I'll round it off to the nearest degree. 217 degrees. So to state my answer nice and clearly at the end, I'll say it is, remember we have a magnitude which has a number, And units, what are the units in this case? Meters. 40 meters at 217 degrees. So it would go in that direction. Okay, well, that's your lesson. Nice quick one. Your homework for this lesson is the second sheet. It's called Vector number 2, and the Minds on Physics projectile vectors and projectiles 2, 3, and 4. Let me see if I have a link to that. Does it go? Okay, so hopefully that's just the second one in your package. Thank you, and I'll see you in class.